hope you did your mental math push-ups in the morning, because you have to do a ton of simple mental math in this method, which makes it easy, but also easy to not pay attention for a second, easy to make mistakes. And so this will be, in this year of calculus and linear algebra math that we do, this will be some of the easiest and also most frustrating math that you will do. Because you will making one tiny mental math error throws the whole thing off, and then you have to start again. So, here you have a systems of equations. I hope you can see this is about as easy a systems of equations to solve as there is. What do you think y is? 2? Yes. It tells you y is equal to 2. And if you knew y was equal to 2, would it be very hard to find x? No. You could just plug it in and solve x is equal to -1. Now, what we're going to do is we're going to make something called an augmented matrix. An augmented matrix still has your square brackets, like we normally have for a matrix. Still has your elements, but we put a line in here where the equal sign is. So it's sort of like putting your coefficients matrix and your answer matrix together in one matrix. You see how I have the coefficients on the left and the answers on the right, just separated by a straight line. This is called an augmented matrix. And we know that this is easy to solve because we already saw that y was equal to 2. Now, Gaussian elimination is all about getting your augmented matrix into row echelon form. Row echelon form just means that there are zeros in the bottom left corner of your coefficients part. So this would be row echelon form for a 2x2 systems of equations. If you had a 3x3 systems of equations, let's say this was my augmented matrix, I would want to get three zeros to have zeros in the bottom left-hand corner. If you have that, you could rewrite your equation. This is a little mini equation. This means 5 times z is equal to 3. Can you see that z is equal to 3/5? And once you know that, this means 3y plus 4z equals 2. And if you know what z is, you could plug it in, then you could find y. And then if you know what z and y is, this first equation means 3x plus 2y plus 1z equals 1. And so if you get an augmented matrix in reduced echelon form with zeros in the bottom corner, then you have an equation like this system where you can solve things easily. Okay? Gaussian elimination says there is methods like the elimination technique that you can use to get your augmented matrix into this reduced row, or sorry, just row echelon form. Okay. So, you start by creating your augmented matrix. If you can't, there would be a straight line in there. You can add that. You have your coefficients matrix and your answer matrix put together with a line in between. And just like the elimination technique, we are going to learn some mathematics with matrices called row reducing operations, elementary row operations. What you are allowed to do at any time in a systems of equations is change 2 rows around. Doesn't change your system of equation if you write the first one first and the second one second, or the first one second and the second one first. They're still the same systems of equations. So we can, at any time, switch 2 rows if we want to. You can multiply a row by any number. Right? If you have an equation, 2x plus 3y.
Attention all occupants. Attention all occupants. This is a lockdown alert.
Well, that's why we're locked out. Yeah, but like, there's like no like windows to like get out of it.
Okay. So we were on our row operations. You can always switch to rows. If you have an equation, just like in the elimination technique, you would multiply that equation by -2, right? So that you could eliminate the first variables. So you can multiply that. And then you can add any two rows together. So when we use the elimination technique that we've learned already, we usually multiply first to get a row to be the same number but opposite signs, because then if you add them together, you would get rid of the x's, and now you could easily solve for y. So what does this look like in matrices? It's actually quite elegant, because it saves you some time that you don't have to rewrite x's and y's. So we set up our augmented matrix. Then I'm going to change my augmented matrix to a new augmented matrix with row reducing operations. So I'm going to reduce row 2 and rewrite row 2 as -2 row 2's plus a row 1. Because I'm allowed to multiply by any non-zero number, and I'm allowed to add or subtract any rows that I want. So this is where the mental math isn't hard, but easy to make a mistake. My goal, and I'm going to circle this spot here, if I want to get it to row echelon form, I want that 1 to be a 0. Can you see if I multiplied this 1 by a -2 and then added it to this row, I would make it a 0. Because -2 plus 2 would be 0. That's what I have explained in this operation. I'm going to make my row 2. I'm going to take my row 2, multiply it by -2 row 2's, and add it to row 1. So if I take this and multiply it by -2, I get -2, add 2, I would get 0. Take the 5, I multiply it by -2, I get -10, add 3, I would get -7. I take 11, multiply by -2, add 8, I would get -14. And what we get in our row here now, our second row now matches up with -7y equals -14.
I have a question.
Yes.
Wait, where do you get the -2 from?
This is where you're going to have to do some mental math, and you have to say, if I want to make this a 0, what could I do to multiply rows by and add rows together to make it a 0?
Oh, he's a fake. Oh no.
I just wrong through it. And then you don't have to write it again. I don't know why I rewrote it again. But once you have that, now you could change your second row back to your equation. All that's left is -7 times y equals -14. You could solve for y. And you could take equation 1, and now that you know that y is 2, you could solve for x. Question?
Wait, why are the numbers slightly different? Oh wait, I see it. Wait.
Like y did, oh, this is a different, oh, I did, oh, they're not, yeah.
Oh, they're two different
They're
ones?
two different ones. I thought I was rewriting it. Let's just ignore the second one. But that's the idea. Once you get it into row echelon form with a 0 in the bottom corner, now you could substitute it back into equations and solve easily. So let's do a couple together. Again, for 2 by 2 equations, sometimes you find it's easy enough just to use your old techniques, that's fine. But as we get to bigger ones, this is a nice way of keeping your data organized and not having to write as much. Because every time you make a matrix, you no longer have to write your x's and your y's, or your plus signs or minus signs. Well, you still have to write the minus signs, because they're held in a place within the matrix. So I set up my coefficients and my answers. And my goal is to make this bottom corner a 0. And I can multiply, I can add, I can subtract. So I want to change row 2. So that's why here I write row 2 is going to equal something new, because that's the one I want to change. How can I make this a 0? Well, if I just subtracted my 2 equations, it would be a 0. If you did 1 minus 1, I would get 0. So I just took row 1 and subtracted row 2. It would be exactly the same if you did row 2 minus row 1. It doesn't matter the order you do things. Like, you've got a lot of freedom with matrices. But now this is where things get tricky. What the heck? Sorry, this is me playing around with some math from previous times. I'm just going to rewrite. I don't know why I multiplied by 3. It's just for fun. But we're not changing row 1. Right? In our arrow there, we're saying we're only changing row 2. So row 1 is staying exactly the same. Row 2 is now row 1 minus row 2. So I take row 1, 1 minus 1, I get that 0 that I wanted. Negative 2 minus 4, can you see that you would get negative 6 if you subtracted row 1 minus row 2? And 10 minus 16 would give me negative 6 there as well. Again, the mental math is easy. You just have to do lots of it, but you cannot make a single mistake. Otherwise, you will get frustrated. So, one thing that's guaranteed to happen in some of these questions is you will get frustrated. You will make a mental math error, and nothing will work. And the best way to fix your mental math error is probably just to start the whole question from the beginning again. Because your chances of finding your mental math error actually take longer than doing it again and doing it a little slower. So once I have this, negative 6 equals negative 6, I can rewrite that back with my algebra. That means negative 6y equals negative 6. So y has to equal 1. And if y is equal to 1, I can use my first row, that 1x minus 2y equals 10, and plug in 1 for y, and solve that x is 12. Woo! Oh, I've added some extras in here. There are your answers. I'd like you to try and get this one. Here's your setup. First of all, rewrite these equations. So I have my answers matrix by itself. I have a column that's just x's, a column that's just y's, a column that's just answers. Your goal is to get a 0 in that bottom corner.
Oh, I was thinking the wrong question. Wait, but did we already do this question? No.
Did I just miss one?
Yeah.
Okay. I skipped one. It's okay.
Got it.
Sorry for the confusion. Okay. We are wanting to solve this 3 by 3. So if I set up my augmented matrix 3, 2, negative 4, negative 20, 1, 1, 1, 4, and 5, negative 1, 1, 18. Our goal is to have, in this bottom corner, the whole bottom corner to be zeros. Now, I could just let you play around with this and you would learn over practice certain techniques. Because sometimes you get 1, 0, but then you do another row operation and your 0 goes away. And so it gets a little bit frustrating. We're going to get those zeros first, and that 0 second. Okay? So I'm going to show you in doing this some of the tricks and techniques that I like to use when solving this. Okay? Notice that when we get those zeros, that whatever's in row 1 will never change. Okay? So row 1's never going to change. We're never going to change row 1. But we're going to use row 1 a lot for figuring things out. Numbers that are smaller are easier to work with. So probably what I would do in this situation is, my very first thing I would do is I would just rearrange this. I'm going to take row 2 and switch it with row 1. And probably if I was setting up my equations, I would have just written it this way to begin with. But I'm going to put row 2 here. That's my 1, 1, 1, and 4. And I'm going to put row 3, 2, negative 4, negative 20. I'm just going to switch those 2 rows because I like having 1s up at the top. Why? It'll make some of our row operations easier. Now we're going to fill our whole page with matrices. And we're going to try along the way to be very careful not to make any mental math mistakes, which includes just copying down numbers is sometimes hard. You found that in that last question, right? Did I write down all the numbers right? Yes, so I just switched them. Now, goal number 1, which I circled in green, is I want to make these zeros first. And you can do 2 operations at once. So I'm going to change my row 2 and my row 3. So looking in that green circle, I look at that 3. I want to make that go away and be a 0. Can you see that I could do that by taking row 2 and minusing 3 row 1s? And if I want to make the 5 equal to 0, I could do that by taking row 3 and subtracting 5 row 1s. So I write my big matrix. not changing row 1, so I rewrite it. I am changing row 2. I'm taking row 2, and I'm subtracting 3 row 1s. Success, that gives me a 0 here. What's left? If I took 2 and minus 3, then I would have a negative 1 there. If I took the negative 4 and subtracted 3, I would get negative 7 there. And negative 20 minus 3 will give me negative 32 there. Everybody good with the mental math of what had just happened? Row 2 got changed by taking row 2 and subtracting 3 row 1s. Now I'm going to change row 3. Row 3 is getting changed by taking row 3 and subtracting 5 row 1s. That will give me a 0 there. I would take the negative 1, subtract 5 1s would give me negative 6. I would take the 1 and subtract 5, that will give me negative 4. And I'll take the 18 and subtract 20, that will give me negative 2. Next, we want to make this a 0. So we want to change row 3 to something new. Can you see, though, that if you use row 1, add, subtract, multiply, anything you do with row 1 will get rid of your first 0. That would be a problem. We have to use row 3 and row 2 because they both have zeros. It was important to get these both zeros first. So now if we add or subtract using just row 2 and row 3, these will stay zeros. Okay? So I want to change row 3. Is there a way that I could take row 3 and use it with row 2? Okay? To get that to be a 0. And you see that if you did row 3, which is minus 6 already, and subtract 6 row 2s, because if I multiply row 2 by a negative 6, I'll get positive 6, then I would get 0. So again, mental math-wise, okay? I figured out a way to make it 0. Mental math-wise, sometimes people don't like working with negatives. You could just take row 2 and multiply everything in row 2 by a negative, and that would change these all to positives. And then working with positive numbers might be easier for you. That's perfectly fine. You have all of the choices that you like, whatever makes your math easier. So I could have taken row 2 and multiplied it by negative 1 and made all of those positive, but I didn't. I'm going to work with the negative and see. Here's my matrix. Row 1 did not change, so I rewrite it. 1, 1, 1, 1, 4. I'm taking, I did.
Sorry for the interruption. All students who are on shuttle bus 2 for the blood donation, please meet in the cafeteria now. That's all students who signed up to donate blood who are going on shuttle bus 2. Please go to the cafeteria now.
My row 2 isn't changing, so I rewrite that. Right? The only row I'm wanting to change is row 3 because I want what's in the purple circle to be a 0. How do I go about doing this? Well, row 3 minus 6 row 2s, do you see that with the zeros, this stays a 0, which is good. Now, negative 6 minus 6 times negative 1 will become 0, which is what I wanted. And if I take negative 4, negative 6 times negative 7 is 42. Negative 4 plus 42 becomes 38. It's kind of a big number. This moment I'm a little scared because numbers over 7 scare me in matrices, but I've got a 38. See how it goes. And then I take the answer, negative 2. 6 times 32, I'm really scared now because 6 times 32 is 192, right? Is that right? Going to be positive 192 plus the 2, 190. So I'm a little bit scared here because those look like not very good numbers. But we'll see, now that I have that system, this would mean that 38z is equal to 190. Does it work out nice? Go to our calculator, do a little 190 divided by 38 and pray, and it works out to be 5. For the most part on your tests and on your quizzes, well, not on the quizzes that are take-home necessarily, but on your test, sometimes I'm going to be nice and tell you your answers are going to be whole numbers. So if you get to z and it equals a fraction, you know you screwed up with your mental math. Start over, try again, go slower. Then you try slower, it doesn't work again. Start over, make sure you wrote down the question correct, because that is the most frustrating thing in matrices. You do it 7 times, it never works, only to realize you didn't copy the question down right. Super frustrating. So now we got z is equal to 5. We go to row 2. If I look at row 2, this means that negative y minus 7 times z, which I now know is 5, has to equal negative 32. Which means negative y equals add 35 to both sides, plus 3. So y is equal to negative 3. And finally, I can look at row 1, which means 1x plus 1y plus 1z has to equal 4. And I can solve that x is equal to 2. At this point, I think this might be nicer than elimination and substitution for a 3x3 when comparing to what you used to have to do. It keeps things organized, and it does the same thing. What are you doing in the green circle? You're eliminating your x's. And what are you getting? In this blue box right here, I have a new system of equations with only 2 equations and 2 unknowns. When we did a 3x3, remember how I had equation 1, 2, and 3 labeled? And then I eventually had an equation A and B. This is, in the blue box, is my new equation A and B. Then, what did we do? We eliminated the y and got a single equation with only z that we didn't need to find. Okay? I'm going to give you 2 more equations to write down. Is this the one? This is no, just one more. Here's one more equation to write down with 3x3. I'm going to give you the answers. They're nice whole numbers. And you have to get your matrix with zeros in the bottom corner. You can write the order down however you like.